As we get started here, I'd like you to think back to the explore and reason we did at the beginning of this topic and what kind of conjecture that you made. Keep that in mind as we explore. For each square, draw a diagonal. Identify what types of triangles you created and calculate the length of the diagonal. So if I have a square here and I draw the diagonal, from here to here, I have created two triangles and I'm cutting these angles in half. So this is 45 degrees and this is 45 degrees here and here. And then let's calculate the length of the third side. And so that third side is our hypotenuse. So I have 1 squared plus 1 squared equals c squared. And 1 squared is just 1 plus 1 equals c squared. So that's 2 equals c squared. And then, of course, we're going to take the square root of both sides, and we get that c is equal to the square root of 2. So we have actually created an isosceles triangle with 45, 45, and it's a square, so this is 90. 45, 45, 90. Okay, let's go ahead and draw our next diagonal. Again, we have 45 and 45 and 90. And because this is a square, the sides are the same, so I have an isosceles triangle with 45, 45, 90. Let's find the length of the missing side. 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. And that's 18 equals c squared. When we take the square root of both sides, I get the square root of 18 equaling c. So c equals, and let's break down that 18 into 9 and 2. So square root of 9 and square root of 2. And we can simplify the square root of 9 is 3 square root 2. So in simplified form, we have c equal to 3 times the square root of 2. Let's go ahead and draw on the last one here. And again, we're ending up with a 45, 45, 90 triangle because it's a square. And we know that these two pieces will be the same length. Let's call those x. So now I have x squared plus x squared equals c squared. So that is 2x squared equal to c squared. And now we need to take the square root of both sides of the equation. We're going to break this down into x squared and the square root of 2. Because the square root of x squared is just x, and square root of 2 is simplified. So the off side is x square root 2. Let's look at the pattern. Note that when we have a 45, 45, 90 triangle, the side lengths are the same, and the hypotenuse is whatever the side length is multiplied times the square root of 2. And that actually comes out that way every time. Now let's look at the ratios for the side length of each square to its diagonal. So we're going to compare, given any 45, 45, 90 triangle, what is the ratio of the leg and y? So let's look at this. The side to the hypotenuse. So if I say okay. Given any 45, 45, 90 triangle, what is the ratio of the leg to the leg? So if I look at leg over leg, I have 1 over 1, 3 over 3, and x over x. So 1 over 1, 3 over 3, and x over x. All of those are going to reduce to 1 every time. Because the two side lengths are the same. So given any 45, 45, 90 triangle, what is the ratio of the leg to the hypotenuse? Well, when we look at the first one, we have a 1 to square root of 2. When we look at the second one, we had 3 to 3 square root 2. And then we had x to x square root 2. Now let's go ahead and simplify those by rationalizing the denominator. So multiplying the top and bottom times the square root of 2 gives me square root of 2 over 2. Multiplying the bottom times the square root of 2 and the top times the square root of 2. Actually, let's go ahead and reduce this first. So that gives us 1 square root of 2 and then over 2. And here, x over x reduces to 1 over the square root of 2, multiplying the bottom and the top, the numerator and the denominator by the square root of 2, we get square root of 2 over 2. So every single time, the ratio of the leg to the hypotenuse is the square root of 2 over 2.